In this video, we are going to learn how to write an absolute value function as well as how to identify its domain and range. Now, we'll start with first talking about the general form of the absolute value function. In general, we always have y is equal to a, which is usually the stretch or compression factor. On the inside of the absolute value, we usually do x minus h plus k, where h and k represent some sort of vertex. And ideally, whatever h is, that's also your axis of symmetry, x equals h. So when I look at this example on the left, we're going to find out what is the equation of that absolute value function, and then we'll identify its domain and range using interval and inequality notation, which I'll go over in just a minute. First, we want to identify what the vertex of this absolute value function is, which looks like it takes place at -1, and then 1, 2, 3, 4, 4. So my vertex will be -1, 4, which tells me that in general form, h will equal -1 and k will equal 4. Next, we need to identify what the a value is. We talked about in the previous lesson that is usually just the slope of the branch to the right. So I can count that, and I can see that it goes down 1 and over 1, 2, 3, which is -1/3. So a must be -1/3. And once you identify these parts looking at the graph, it's pretty simple just to plug all that into general form and get your equation, which will be y is equal to -1/3 times the absolute value of x minus -1 and then plus 4 for k. Just plug it in h and k. Now I have x minus -1, so my final answer will be x equal to -1/3 times the absolute value of x plus 1 and then plus 4. And that'll be the equation for that graph. Definitely not too bad to figure out. Now next I want to talk about what domain and range are. Now domain, to put it simply, is the list of all possible x values. And then more broadly, it's the list of everything you can use independently for the independent variable. Now the range is all possible y values, to put it simply. But in general, it's the range of values you get after plugging in all of your independent variable values. So it's kind of your dependent value range. Now to put this in inequality notation, you're just looking at what's everything I can plug in, looking at my x-axis. Now it seems like everything could be plugged in, especially looking at this down here. I could plug in any x value I want. So in inequality notation, that would go from negative infinity is less than x, which is less than positive infinity, meaning that it's greater than the most negative number you can think of, and also less than the greatest possible positive number you could think of. So it just means everything. Now if I were to put this in interval notation, I just simply write the beginning and ending numbers of the interval. So looking at this, it goes from -infinity to positive infinity. So I just write those two numbers. So from -infinity to positive infinity. Now, do I want to include those numbers or exclude them? Now, if I want to include them, I will use brackets, these little boxes. If I want to exclude those endpoints I just wrote, I'll use parentheses. Now, infinity and -infinity aren't necessarily real numbers that we can use tangibly, so we'll always have to exclude infinity, since it's not an actual number. Now, the range of this graph, looking at it, doesn't seem to go up all along the y-axis. It actually seems to have a cap as the highest it goes. But from the high point, it looks like it just go down forever. So for an inequality, I can say that y is less than or equal to 4, since that seems to be the highest y value you can reach. All other y values are going to be below that 4. But in interval notation, the way we write this is, again, from the beginning to the ending. So the beginning is as low as you can possibly go, which is going to be negative infinity, to the highest you can go, the ending number, which is 4. Now we cannot include negative infinity, but we do want to include that 4. So I'll use a bracket to include the 4. And that is interval notation. So let's try this out one more time with another example, and this time we'll bounce back and forth between the forms. So looking at this graph, I can see that my vertex is at negative 2, negative 1. So h is equal to 2, and k is equal to negative 1. A in this case, it looks like it goes up 1 and then over 4. So A should equal 1/4. Writing that equation, I'll get y is equal to 1/4 times the absolute value of x minus 2 and then plus negative 1, which when simplified gives me the equation y is equal to 1/4 times the absolute value of x minus 2 minus 1. So there's my equation. Its domain, again, looks like it's going to cover every x value I could possibly imagine. So it's going to be negative infinity is less than x, which is less than positive infinity. Or in interval notation, negative infinity to infinity. The range looks like it has like a low point, but it can be any positive number above it. So y must be greater than or equal to negative 1. And the way you write that interval notation is now that's the beginning point. So negative 1 to positive infinity, because it looks like it'll keep rising to any y value we could imagine. We want to include that negative 1, but again, we cannot include infinity. And that is how you write an absolute value function and find domain and range.